Welcome back to the ARSET training, Monitoring Global Terrestrial Surface Water Using Remote Sensing. My name is Sean McCartney. I'm an ARSET trainer at NASA's Goddard Space Flight Center. I'm pleased to welcome you all to the second and final part of the webinar series. The following slide provides a review of what was covered in part 1 of the training. We provided a review of altimeter-based lake level height data from historical and current missions, along with data access via the Global Water Measurements Portal, an online source for satellite data products relevant to lakes, reservoirs, river channels, wetlands, and global mean sea level. We also provided an overview of the Surface Water and Ocean Topography mission, known by its acronym SWOT, along with data products and hydrology-relevant Level 2 data. Data access was provided through NASA Earth Data Search and Hydrochron API. And SWOT applications were highlighted along with NASA's Early Adopters Program. As a reminder, there are 2 prerequisites for the training. The first is our Fundamentals of Remote Sensing course, and the second is our Mapping and Monitoring Lakes and Reservoirs with Satellite Observations. Links to both those ARSET trainings are provided below for your reference. Over the 2 parts of the training, we provided an overview of remote sensing observations for monitoring global terrestrial surface water in large rivers and lakes in part 1, and today we'll be learning about SWOT mission applications and access for retrieving, visualizing, and manipulating data. All materials and recordings from each session can be accessed from the training webpage. Homework opens today, May 15th, and will be due on May 31st. You can access the homework from the training page. A certificate of completion will be awarded to those who attend all live sessions and complete the homework assignment by the given due date. For part 2 of the webinar series, SWOT mission applications and access for retrieving, visualizing, and manipulating data, we're delighted to be joined by 2 guest instructors. Dr. Merritt Harlan is a Mendenhall Fellow and Research Hydrologist for the United States Geological Survey's Water Resources Mission Area based in Lakewood, Colorado. Dr. Harlan's research focuses on remote sensing of inland waters with a particular interest in high-latitude rivers. Dr. Harlan is interested in applying data from satellite missions to estimate river flows in ungauged basins, assess changes in surface water in high-latitude lakes and rivers, and compare and evaluate the accuracy of satellite-derived stage and stream flow to field data and modeled data. Dr. Michael Durand is a professor and associate director for graduate students at Ohio State University. Dr. Durand and his research group study land surface hydrology processes with a focus on using space-borne remote sensing measurements to answer open science questions in snow hydrology and in fluvial hydrology. We are delighted to have them both joining us today to provide their expertise to this training. By the end of part 2, participants will be able to identify ways to apply SWOT data for water resources and disaster management applications, and recognize how to utilize the SWOT Rivers data visualization tools such as SWOTViz and WISP to monitor water availability and flooding potential. The outline for today's training is as follows. Dr. Harlan will provide an overview and demonstration of the Water Information from Space, or WISP. WISP is an interactive dashboard with real-time satellite hydrology data and streamflow and water level data from the United States Geological Survey. WISP is designed to familiarize users with different satellite data products and contextualize these data alongside ground measurements within the United States. Dr. Durand will provide an overview and demonstration of the SWOT Data Viewer application, or SWOTViz. SWOTViz is an interactive web user interface featuring mapping and plotting capabilities for retrieving, visualizing, and manipulating SWOT data on a global scale. Please place your questions in the questions box, and we will address them at the end of the webinar. Feel free to enter your questions as we go. The question and answer document will be posted to the training website within a week of today's training. I'll now pass it over to Dr. Harlan to present on Water Information from Space, or WISP. Merritt, over to you.
Hello, my name is Dr. Merritt Harlan. I'm a research hydrologist with the U.S. Geological Survey Hydrologic Remote Sensing Branch, and today I'm going to be talking about a new USGS data portal, Water Information from Space. For today's presentation, first I'll give an overview of the Surface Water Ocean Topography, or SWOT satellite, following on to the previous presentations in this webinar. Then I'll give a quick demonstration of the public data portal, Water Information from Space, or WISP, and I'll close with some varying water management applications using SWOT data. SWOT is a collaborative mission between NASA and other international space agencies, and the satellite is designed to monitor both ocean and inland waters, but today I'll be focusing on inland waters. And SWOT uses a wide swath Ka band radar interferometer to measure simultaneous elevation as well as width in areas. And having both of this data at the same time allows us to then estimate volumetric changes such as stream flow or lake storage change. SWOT data are available starting around March of 2023, and SWOT is a global mission. For today's data portal demonstration, it's focused on data within the United States, but data is available throughout the globe. And SWOT has repeat coverage in mid-latitudes on average every 10 days or so within the United States, or 2 days within a 21-day orbit cycle. But there's more frequent coverage up at higher latitudes, such as in Alaska, with data every 3 to 6 days. In the US alone, SWOT is measuring over 467,000 lakes and reservoirs and over 93,000 river miles, which is greatly increasing the number of water bodies that we have available data for. If we zoom into different parts of the US, we see coverage in Denver, Colorado, for example, where I'm from, showing varying lakes as well as the South Platte River. And if we look at Washington, D.C., we see the Potomac River showing up as well as some lakes and reservoirs. We see the real potential of SWOT if we look in the Yukon Delta and zoom out and see the thousands of lakes and river reaches that will be observed by this satellite. As mentioned earlier, there's varying types of SWOT water data. And the vector-based products include a river reach as well as a river node. Reaches are broken down into roughly 10-kilometer segments of the river center line. And nodes break these reaches down further into points along the center line spaced every 200 meters. We also have lake and reservoir data, which are represented in this case by these static polygons you see here on this data portal. Now I'd like to transition to talking more about Water Information from Space, or this new website that allows folks to go and download data from SWOT across the United States. And you're welcome to scan this QR code to directly access WISP or follow along with me at this URL. This dashboard came about through a collaboration between the U.S. Geological Survey and NASA's Jet Propulsion Laboratory in Podest. On NASA's side, they developed the Hydrocron Application Programming Interface, which takes SWOT vector-based data and turns it into time series data. This Hydrocron API has allowed us to seamlessly access SWOT data through this portal and is a great tool for visualizing SWOT data. I'm going to share a quick overview of some different features on this dashboard now. So we have a tutorial page that provides an overview, which I won't go into in detail, but wanted to highlight that it's there if you ever want to dive in deeper. On the left here, we have a data menu where you can toggle on or off certain layers based on what you might be interested in viewing. And all of the features that you see here on the map are clickable and will take you to a time series of a region that you might be interested in. For example, I'm viewing here river reach data from SWOT as well as river node layers. And if I click on a point, that is near a gauge, I'll see a time series of both SWOT and a gauge pop up, which I'll go into more detail with later. If a site is near a gauge, you can also directly click to that gauge site. And we also enable users to directly download data into a CSV format that they can readily open and view the data for themselves. The CSV is enabled through that Hydrocon API, which I mentioned. In addition to river data, we also include SWOT lake data on this portal as well. And users can click on a water body they might be interested in and view the time series from SWOT there as well. In addition to this main map interface, we also include an informational page on SWOT that has some varying resources and more information about the collaboration between the U.S. Geological Survey and the SWOT mission. We also include a feedback page, and we're actively looking for users to provide more feedback on how we can improve this site. We also have a frequently asked questions page that additionally includes some resources. At the bottom of the site, we link to varying data sources, including the Hydrocon API, which I've been mentioning. And this is a great tool, for example, for batch processing data and querying data across multiple rivers. Now I'd like to transition to talk about different use cases for SWOT data. One example is that SWOT is actively capturing flood events. For example, in June of 2024, there was a flooding event in the Blue Earth River in Minnesota. And we can see here on the left y-axis of this pop-up chart that we're seeing SWOT water heights shown by these black points here. And on the right y-axis, we have USGS gauge height. And you might notice that the values for SWOT and gauge are different, and that's because SWOT is referenced to an Earth gravitational model, and we're showing the gauge data in meters based on the arbitrary gauge datum. So we're showing a relative comparison, but the range is the same. And in both cases, we see that there's a stark increase in the water level from both SWOT and the gauge during this flooding event. If we now go to the WISP site, we'll zoom in to the Blue Earth River, and we can search for a given river by name. And that will zoom us on into this site in Minnesota. We can toggle on a gauge layer to see this direct comparison between SWOT and a gauge. And here again, we have SWOT water height shown in those black circles and gauge height shown in green. And what's so exciting about SWOT is that we're able to access this elevation information not only where we have gauge data, but also upstream and downstream, so that we can see the impacts of changes in water elevation throughout a whole region, including in nearby lakes. Another example of how we're using SWOT data with different partners is through a collaboration with the U.S. Department of Agriculture. The USDA provides technical assistance for thousands of dams and reservoirs throughout the United States. Many of these sites are flood control dams, and predicting when a dam is going to have a spillway flow, which could cause downstream damages, is very important, but it's difficult because many of these dams and reservoirs don't have any sort of in situ monitoring on them. SWOT, however, is observing changes in elevation over time, and these changes in elevation can help improve models of when spillway flows are going to occur. In order to see this data within WISP, we can zoom into the state of Oklahoma and toggle on the SWOT lakes layer in order to see that data from nearby lakes. First, I'll show a reservoir that happens to have a USGS gauge co-located with it. And again, we see that time series of SWOT alongside a gauge time series. And we can again download the data if that's of interest. But we also have SWOT data on thousands of lakes that don't have any sort of long-term in situ monitoring. And so we can also view time series there. Another example I wanted to point out is how we're using SWOT data in Alaska to help with the design of safer bridges. Here's an example on the Knik River, where we've been working with the Alaska Department of Transportation, who's interested in ingesting SWOT data to improve their hydraulic models to inform safer bridge design. In order to access this river data within WISP, we can zoom into the state of Alaska. And here I'll be looking at the river by reach layer. And I can search for the Knik River and zoom into that site to access the time series data there. So here's an example of a river location where we don't necessarily have a gauge, and we can use SWOT data to inform how the elevation changes in different parts of the year, for example, during ice breakup or during the summer season. And that was my short tutorial, but I wanted to end it with some takeaways. One is that SWOT is really vastly increasing the number of water bodies we can measure globally. And if you're interested in SWOT data within the United States, I really encourage you to check out the Water Information from Space dashboard and discover your own use for SWOT data through this site. I also wanted to thank the team that has been working with us to develop Hydrocron, and as well as the data products that are hosted by Podak. And I also wanted to thank the WISP developers, Chuck Hansen's team within the USGS California Water Science Center. Please don't hesitate to reach out with any questions or ideas for how to improve this site or collaboration possibilities. And thank you for your attention and time.
I'm so excited to be here. I'm presenting this web application, SWOTViz, that explores and visualizes SWOT data globally. My name is Mike Durand, and I'm a professor at Ohio State. And I've worked for a long time with Merritt, so we are kind of thrilled to present both of these visualization tools kind of side by side. And she's already talked a lot about SWOT. You've already heard about SWOT from Matt Bonnema. And so we're just going to dive straight in here to what SWOTViz is and some of the things you might be able to do with it. Here is the link. This is SWOTViz. It is a tool that enables global SWOT data access and exploration. And you can either hit the QR code or it's just swotviz.quasi.io. Quasi is the consortium of universities allied for hydrological science. If you don't know of the org, but they do a lot of really cool things to make hydrologic data accessible, and they have done a lot of hard work here to create a fast and usable app for this. And so the big thing that distinguishes SWOTViz from WISP, which you've already heard about, is that SWOTViz is global, allows global data access, and it's not quite as feature rich as WISP, but when you need to look outside the US, it's a great place to start. Just a little bit more about the app before we dive into using it. SWOTViz allows retrieval, visualization, and a little bit of manipulation, and also download of SWOT data. So as mentioned before, was built at Quasi. It's super lightweight. We prioritize that throughout. It's not about having lots of features. There's multiple other ways of other apps out there. And I did want to highlight the amazing API that we've been using, the Hydrocron service. So if you Google Podak Hydrocron, this is built by NASA scientists with a big shout out to Nikki Tabaldi. And this is what enables SWOTViz to work so fast. And then I wanted to highlight funding support from the NASA Water Resources Program. This was built to help initially our colleagues in actually Alaska and the water resources program there to help end users in Alaska access SWOT data and explore quickly. So enough about the app, and let's go and explore just a little bit. So as we start the demonstration of the SWOTViz app, again, we're at the swotviz.quasi.io site, and it loads a map of the whole world. Again, the key thing with SWOTViz is it allows you to explore SWOT data globally and not just over the US. So let's start in Brazil on the Amazon River, and we'll look at this one reach on the Amazon. Of course, the Amazon, biggest river in the world by any metric. The flow of the Amazon is about 10 times the Mississippi, as I'm sure many of you know, and many of you probably teach in your classes. The Amazon, as we're waiting for the data to load, is interesting in that as the seasonal rainfall patterns move back and forth with the seasons and the ITCZ, the solar radiation maxima, you get this characteristic annual cycle. So I've just gone into the time range over on the left in the SWOTViz, and the graph is plotting water surface elevation on the main stem Amazon, and here you can see that nice smooth seasonal cycle over about a year plus of data. And several other things to call out. You can see how huge the Amazon is here. The water elevation here is peaking at about 10 meters and bottoming out at about 2 meters. So that's an 8-meter annual flood wave, 24 feet of water change for our English unit users. So you can actually see the different data quality flags throughout as well. And these are part of a wealth of data that are produced as part of SWOT. SWOT's an experimental mission. There's never been anything quite like it. The Ka band radar interferometer is the key instrument there. And so interestingly, you can actually see that around this time in October, the data quality changed. Whereas prior to that time, it was usually suspect. After that time, it's usually degraded, which is interesting. Basically ticking down one level. And that is because of something else that's useful to draw your attention to, which is that, in fact, the algorithms changed a bit around late October. And so I'm not too surprised to see a change at that time. And nevertheless, despite the fact that these are flag degraded, you're still getting a lot of useful information, most likely out of them, as this looks about like how I would expect. Let's look at a smaller river. So really, existing altimeters could measure the main stem Amazon. One of the things that SWOT does is it allows you to see everywhere. So now we're going to go to a smaller tributary, just upstream of the reach we were looking at earlier. So when you click on a reach in SWOTViz, it pulls up some nice metadata, including the river name. And here it tells us that the river width here is 300 meters, which is still quite large actually for SWOT. When we pull up the plots for that particular river reach, we're now going and retrieving the river time series elevation for that reach. You see this interesting kind of sawtooth pattern going on. And what you notice is that the data flagged suspect, which is pretty good, not as good as it might be. But when we step down to degraded quality, that's when we see these higher points. And so in SWOTViz, you can just turn off those degraded data points and you have some more likely usable information on the river at the other times. SWOT produces really dozens of additional higher, kind of more granular data flags as well. And while SWOTViz doesn't expose them, they do exist. So you can dive further into the details for those. So we've looked at a couple of rivers in Brazil. Let's go to France. And we're going to go to the city of Bordeaux. to the Garonne River near the downstream terminus there. And so here we are in France. Here's the city of Bordeaux, and here is the where the Garonne River empties into its estuary. And so we'll grab one of these coastal reaches here. Again, the river width's very large here, and you can see the water surface elevation average is about a tenth of basically sea level, right? We'll grab the water elevation time series here, and we do that, we'll see some interesting things. While this is loading, I'll just mention that the tidal cycle, of course, is very interesting here. If you had hourly data, you'd be able to resolve, of course, the daily and sub-daily changes in the water elevation as a function of the changing tides. When you look at a year of data, you actually see a sinusoidal pattern. And while that is not the extent of the tides, it's still very interesting. SWOT's orbit is designed so that it is non-tidally aliased. And what that means is that you actually, over a year, do get a chance to see the SWOT measurements at different points in the tidal cycle. And so you have a lot of information about how the tides work here. Just as a reminder, we've turned the degraded value data off. In this case, the degraded value data don't look too bad, so I'm going to keep them on. This is the water elevation. We're also going to look at river slope. And so when you take a look at the river slope, again, the degraded values are pretty noisy. One of the things that you can see here are the values of the river slope going negative at some times. And we're going to kind of zoom in on about from May 5th, May 1st, 2024 to the current time. And you can see some interesting things. Again, the river slope is positive and then it goes negative. So what we want to do to maybe dive a little further into this is actually look at the shape of the water elevation profile, or the longitudinal profile, the water elevation versus distance. And while I don't want to make too much of a deep dive here, I'll just mention that when we do that, we'll be going from looking at the node data to the reach data. From the reach data to the nodes. And so we've so far been looking at things averaged over an entire 10-kilometer reach, and now we'll look at data that's resolved more like every 200 meters downstream or so. And so you see some interesting things here in this particular profile. First of all, the x-axis is now the distance to the outlet, so the higher values to the left are further upstream. And this lowest elevation profile is actually one in which the water elevation is doing the expected thing and decreasing as you go downstream. And this is what you have, of course, in most rivers. But in a coastal river with tidal impacts, you have the water elevations increasing with the tides. And SWOT can actually show you how that's working. So you see the water is higher downstream here due to the tide, and so you can actually see the water running basically backwards, which is a really cool thing that you're able to see in these tidally impacted areas. And so we're going to go to one more place, to the Copper River, which is near Lake Miles in Alaska. Sorry, Miles Lake. Oh. There we go. And so here we're looking at now a seasonally frozen river. And we're going to be looking at the copper just upstream of Miles Lake. So while we're near the downstream end of the river, we're not tidally impacted anymore. The copper here is about 500 meters wide. And this is a special river for me, in part because as I mentioned, a part of designing this app was so that end users, as part of a project that I've helped to lead over these past few years through the NASA Water Resources Applied Sciences program, to expose SWOT data to folks considering using it um, for end user applications, right? Water management applications. And so this is a couple interesting things about this particular river. So this is seasonally frozen. You'll see that SWOT actually is producing some observations, for example, here in February, where the river is almost certainly frozen. And I would, the ice flags as part of the data product are useful if you want to kind of dive deeper, even though those aren't exposed here in SWOTViz. But I would just bear in mind that sometimes these rivers do freeze, and that doesn't mean that these water elevations are necessarily as precise as they may otherwise be. But you can see parts of the seasonal cycle here on the copper as it increases in the summer months with increased snowmelt and glacier melt upstream. And this is an important reach and special one for me because some of our colleagues at the USGS Alaska Science Center are making river discharge measurements that will ultimately inform the SWOT discharge data products that are going to be part of the project going forward. And again, those aren't exposed right now as part of SWOTViz, but they should be in the future. And so users from anywhere in the world, once our systems are fully built and tested, will be able to add their river discharge in different places and have SWOT discharge accurately track in those places as well. And that will complement some of the other SWOT discharge efforts that we have ongoing. But in any case, that's future work. For now, that's a little bit about how SWOTViz works and some of the interesting things you can do to explore SWOT data from this interface. Thanks.
Thank you so much, Dr. Durand and Dr. Harlan, for the wonderful presentations and demonstrations. To summarize what we've covered in both parts of the training, monitoring surface water extent and amount are crucial for sustainable water and disaster management. The latest NASA mission, Surface Water and Ocean Topography, or SWOT, measures global ocean surface topography and land surface water extents and elevation with great accuracy. Level 2 products are available from SWOT in point cloud of water mass pixels in NetCDF format, surface water elevation and inundation extent, vectors of river reaches and nodes in shapefile format, and vectors of lakes in prior database and detected features not in prior databases, also in shapefile format. Data access was shown in both NASA Earth Data Search as well as the Hydrocron API. And WISP, which was demonstrated today, is a web tool for water management applications in the United States. And SWOTViz, also demonstrated today, is a lightweight web app that allows quick visualization of SWOT river data globally. Before we proceed to the question and answer session, I want to remind you there will be one homework assignment accessible from the training webpage. Answers must be submitted by Google Form with a due date of May 31st. To receive a certificate of completion, you must attend all live webinars and complete the homework assignment by the deadline. You will receive a certificate via email approximately 2 months after the completion of the course. The ARSET program would like to thank once again Dr. Harlan and Dr. Durand for contributing their time and expertise to this training. The program would also like to thank Perry Otto, Program Coordinator for the Water Resources Program, for his contributions to this training, along with the Greater Water Resources Program. Below is the contact information for Dr. Harlan and Dr. Durand, along with links to the ARSET website and social media. Below are resources for the materials presented in today's training. We will now transition to the question and answer portion of today's training. Please submit your questions and we will get to them in the order that they were received. We will post the question and answer document to the training webpage within a week of today's training session. Wonderful. And we want to thank everybody that have been submitting questions. We've gotten some really terrific questions so far. So thank you to everybody who has submitted. There's still plenty of time. We're going to now go to the first question in this question docket. So question number 1, how can SWOT altimetry be leveraged to detect and monitor the influence of the 18.61-year lunar nodal cycle on tidal heights and wetland hydrology in mangrove-dominated deltas like the Sundarbans? And whoever answered this, please feel free to unmute.
Take this question. So SWOT has only been collecting data for a couple years now, and so we don't really recommend trying to leverage this data set to study long timescale processes.
Okay, great, thank you, Angelica. Question number 2. I thought on Tuesday it was said there are observations every 21 days.
Yes, that is true, that a given pass will occur every 21 days. However, an alternative pass may cover the same location over land, and so you might retrieve data with a higher frequency than that 21-day period.
Okay, great, thank you, Angelica. Question number 3, is WISP valid over the United States only?
Yes, WISP is only over the United States, but SWOTViz is a global facing dashboard.
Okay, thank you so much, Merritt. Question number 4, what is the difference between node and reach?
So SWOT data can be found along stretches of a river that are about 10 kilometers long, and this is what we would call river reach, and these come from an a priori database that feeds into the processing algorithms, but also at nodes, which are essentially points along the river. And they're just, to simplify it, it's essentially whether you're looking at a stretch of river or at a point.
Okay, wonderful. Angelica, thank you so much. Question number 5, how was the reach vector dataset generated? Is it based on the National Hydrology dataset?
For the details of the individual data set generation, we have a lot of documentation that can be found both in the user handbook and then specifically in the product description document. And if Mike or Merritt want to add anything to this, feel free.
I was just going to add, this is Mike, I was just going to add that the underlying reaches and the nomenclature and the like center lines are all based on the SWOT a priori river database or SWORD, and you can find info about that at the link I'm sharing in the chat.
Great, thanks so much, Mike and Angelica. Question number 6, how to get the historical data from WISP? From when has it data?
Yeah, this is a great question. So WISP is currently displaying the full record of available SWOT data. And so if you click on, for example, a reach or a node or a lake, on the pop-up chart, it will show the full time series of data that's available, but we do apply some basic filtering where we remove bad and degraded quality data in those pop-up charts. But the full record of SWOT elevation data is also available through Hydrocron and through the WISP data download button. And we also display some other data sets like USGS water level data collected at gauges, and these have denser historic and real-time data, which can be available to access through the links provided on that data download. We also display historic records for our remote sensing of river discharge data and satellite altimetry data as well. And these full records can also be accessed by that download data button.
Wonderful. Thanks so much, Merritt. Question number 7. I'm wondering how to change elevation data to the datum we are using. In this case of Finland, the datum is called N2000. We change the datum regularly because of post-glacial land uplift, an update of datum approximately every 30 years.
So we generally don't give guidance on transforming the data to any individual datum, but there is some additional documentation and a webinar dedicated specifically to describing the reference frame of SWOT observations and how one might approach trying to compare to data sets that are in a different reference frame. And I've put the links there.
Great. Thanks so much, Angelica, for answering that and also providing links for the participants that were interested in that, maybe potentially somebody from Finland. Question number 8, what data product is WISP visualizing?
WISP is visualizing the SWOT level 2 hydrology data on river reaches, nodes, and lakes, but we also display water level data from USGS gauging stations that's measured in situ. And we also show satellite-based river discharge in Alaska from historic altimetry data, as well as other altimetry data from NASA's Global Water Measurements site.
Great. Merritt, thank you so much. Question number 9. Is it possible to access the cloudburst data using SWOT?
This is the pixel cloud data, I might assume, and yes, it's definitely possible to access it. We do not display the pixel cloud data within WISP, but there are a lot of tools on how to access this information in the SWOT cookbook, for example, which I can post a link to. And yeah, Angelica or Mike, feel free to chime in as well.
Yeah, so we presented a fair amount on the Pixel Cloud in part 1 of this. I just wasn't quite sure that that was what this question was asking. Definitely, I can put some links in the document for this question if that isn't the intended answer that they were looking for.
Great. And whoever asked the question, please feel free, if you want to clarify anything, feel free to drop a comment in the chat, and hopefully we can circle back to that. But Angelica and Merritt, thank you so much. Question number 10, does the WISP portal provide real-time data over lakes?
It does, yes. We do apply some filtering of SWOT data in those pop-up charts, which I mentioned, but we do provide lake data on lakes where it's available, and the full record is able to download with that data download button.
Okay, Merritt, thank you so much. Question number 11, can WISP be integrated into ArcGIS?
That's a great question. So we did not design WISP to have like an API endpoint, but we are actively using Hydrocron to access the SWOT data. And I think it might be possible to integrate Hydrocron with ArcGIS. And I'm not sure if Angelica, you would like to talk about it, but I know there are also some preliminary plans to develop some web services that would allow for the visualization of some SWOT data in an ArcGIS-like environment.
Yeah, so there are shape files available from Podak directly that you can import into GIS software. And we also have worked with Esri to come up with workflows that leverage the NetCDF files. But this also is an ongoing line of work in trying to to get things more accessible and definitely continue to monitor the Kodak and SWOT websites for new ways to integrate SWOT data with GIS software.
Wonderful, Angelica and Merritt. Thank you so much for that answer. Question number 12. In WISP, there's a huge gap between the SWOT water height in meters and the USGS, United States Geological Survey, daily gauge height in meters. Why is there a gap?
That's a great question. If there's a specific water body you'd like me to look at, please feel free to email me. But right now we're displaying a relative time series of SWOT and USGS, where we're taking the mean and normalizing both data sets. And that is because for SWOT, it's referenced to the EGM 2008 datum, and our USGS daily gauge heights are referenced to sometimes different datums, like NAVD88. And so instead of applying a datum correction, we're showing both time series on two different y-axes. And there can be a gap sometimes due to, an outlier throwing off this mean, or potentially, errors in SWOT data or kind of differences in the two data sets.
Okay, wonderful. Thank you, Merritt. Question number 13. In the case of large lakes with important changes in depth, how do WISP calculate the lake water height? Is it an average of pixels?
That's a great question as well. So WISP directly takes SWOT data from hydrogram, and so the elevations that we're seeing are an average of the data across the lake surface that the satellite is observing. So it would be an average of pixels in that sense. And that information on how they're averaging pixels can be found in the product description documentation that I believe Angelica has provided some links to as well.
Okay, wonderful. Thank you, Merritt. Question number 14. In SWOTViz, there are regions with densely packed river reaches and regions with almost negligible river reaches. What can be the reason for this? If this case is correct, can we get information where the regions are having no river reaches?
Yeah, I took a crack at this, but please chime in, Merritt and Angelica and others. So yeah, I mean, I guess there's two parts. SWOT produces river data products wherever there are reaches defined in this a priori data set, SWORD, which was mentioned earlier, and there's a link. SWORD's based on Landsat, which was 30 meters, the data products they were using. So, they're able to define rivers down to, 30, maybe 50 rivers more accurately. So we have rivers anywhere that they were in Landsat in SWOT. But of course, there's also the underlying fact that the density of the river network at a particular width, such as 50-meter rivers, is going to be a function of climate. So you've got a lot more rainy places, you'll have a denser looking river network.
Great, thanks so much, Mike. Question number 15. Is the WSL from the mean sea level?
Yeah, if someone wants to chime in, please do. I just wrote that the water surface elevation, WSE, is the main thing that we were looking at earlier in the apps, and that's defined as meters above the EGM08 geoid. If anyone wants to chime in and correct my terminology there, please do.
Okay, great. Thank you, Mike. Question number 16. In SWOTViz, are there lake levels or just data over rivers?
It's planned to add lakes to SWOTViz, but they're not there right now.
Terrific. Thanks, Mike. Question number 17. When I use SWOTViz, I often get empty data and the comment, more lake data coming soon. Is there a way to see that before having to click each item?
But yeah, we're going to hope to add lakes in the future.
All right, Mike, thanks again. Question number 18. Can you explain what granules mean in SWOT context?
I can take a crack at this too, but please someone chime in. I think it varies depending on the data product. As you remember from the first part of the session, there's the pixel cloud, and then there's vector products at points and lines for rivers, and then there's vector products for polygon. So the granules are defined slightly differently. And rather than getting into that, I would recommend checking out the product handbook. It's a really great resource. Or the user handbook.
Great, excellent. And we will update a link to that user handbook when we publish this on the training page. So do look for that. But thank you again, Mike. Question number 19. When will SWOTViz incorporate version D of the SWOT data? In the current version C, most data points are flagged as suspect. Will this change in version D?
Yeah, I wrote this answer too. But again, please chime in, others. But yeah, I don't know when we're going to switch it over to show version D. I think we are not planning to show them at the same time. At least that's my thought. And so right now, or very soon, I believe it's already happened. The new cycles are processed with version D, but the old cycles going back to the beginning of the mission have not been processed for version D yet. And that actually takes quite a while, takes a little while. So depending how quickly that reprocessing goes, we'll make a decision about when to switch SWOTViz over. But I think that'll be sometime in the autumn. The other part of the question, yes, most data is flagged suspect, and we do expect less data to be flagged suspect and more to be flagged good with the version D flagging system.
Terrific. Thanks again, Mike. Question number 20. So what is the difference between WISP and SWOTViz? What is the minimum reach width both of these can cover?
You want to take that one, Merritt, or I can, but I've been answering for a while.
Sure. Yeah, your answer sums it up pretty succinctly. So WISP, the main difference is that WISP is really only showing data available in the US currently, and SWOTViz is available globally. WISP has a couple of more features, for example, the SWOT lake data and the integration with the USGS stage data and some other data sets, whereas SWOTViz is a little more lightweight. And for the minimum reach width, both of these can cover, the science requirement for SWOT is 100 meters wide, but both applications are showing the full set of river reaches available in the SWOT river database, or SWORD, which includes rivers down to about 50 meters wide.
Okay, wonderful. Thank you so much, Merritt. Question number 21. How the data quality was defined as good, bad, and suspect?
Yeah, so I'll take a first crack at this. So, there's quite a significant processing chain that flags data quality at like the lowest levels. So the data products that kind of come before the pixel cloud, the SLC, and the look complex imagery. And then those flags are passed onto the pixel cloud, which are passed onto the nodes, which are passed onto the reaches in the case of reaches. So there's a whole processing chain there. And it's fairly complex, but the key things to know is that it, uses SWOT data mostly. So it says, oh, I don't have enough pixels, for example, to get a good estimate of this node. So I'll flag it a bad way, for example. Though there's much more complex and details there. But please see the user handbook and the product description document. More info.
Great, wonderful. Thank you, Mike. Question number 22. Are the water level elevations shown in SWOTViz referenced to mean sea level or another vertical datum?
I think we answered that above, but yeah, they're referenced to EGM 08.
Great, thanks, Mike. Question 23. Can the data from SWOTViz be downloaded, and does it have the ability to help evaluate floodplain prone areas?
Yeah, so SWOTViz you can download. I forgot to mention that and apologize. But yes, once you're looking at the data, there's a download link. Yeah, evaluate floodplain prone areas. I mean, it depends, of course, on the evaluation that you're trying to make, but I think a couple of things to keep in mind are that SWOTViz is a vector product, right? So it takes the SWOT pixels and maps them onto a center line in one dimension. And that's a good thing to do, when you're trying to understand global hydrology. For floods and floodplain prone areas, you might consider looking at the pixel cloud, since that is in 2 dimensions. And for example, if any processing, weirdness creeps in because you're trying to represent the river as a 1D process in a 2D flow environment, the pixel cloud would be better for that.
Terrific. Thanks, Mike. Question 24. In SWOTViz, is the data quality from the SWOT water pixel cloud data?
So, yeah, I think the data quality, and I'm pretty sure this would apply to WISP too, but the data quality flags that we're displaying are the flags set for either the reach or the node product. I didn't spend a lot of time talking about the difference between reaches and nodes necessarily in the presentation, but I think they've been discussed in part 1 of this training. So it's showing the quality for the pixels and the nodes. And as I mentioned earlier, the pixel and node quality flags are set by the quality of the pixel cloud data and other factors.
Okay, thanks, Mike. Question 25. I noticed that data are mostly suspect. Does this influence the accuracy of readings? And if so, to what extent does it affect?
So the data being classified as suspect is intended to let the user know that somewhere in the processing chain, something was triggered that was unexpected or out of a certain range, or gives an indication that you should treat this data with caution. Now, as the algorithms develop, some of those flags will be changed. And so this is a point that I will reiterate, that in version D, we anticipate that less of the data will be suspect due to improvements in the processing. So I would suggest that who's ever interested, go ahead and check the new version to see if the data remains suspect. And if it does, then you would treat it with caution. It's not necessarily bad, but you have to be a little bit aware of potential erroneous data.
Thank you, Angelica. Question number 26. Why was the Miles Lake grayed out in the SWOTViz? Are there no SWOT data for the lake, and why is that so?
So SWOTViz, as I mentioned, this was answered a couple of times, but yeah, lakes are not available in SWOTViz right now.
All right, thank you, Mike. Question 27. Any thoughts on the future of SWOT? Timeline of if and when smaller river stream systems could be added?
I can take a first cut, but please chime in. So we hope SWOT keeps flying for many years. The mission lifetime is 3 years. But if the satellite's operational, we hope that its mission life will be extended. Its data will keep being produced. Timeline. So I think there are folks that are trying to work on including new, smaller streams in SWORD. I don't believe those will be in version D, but I have not kept super close track of that effort. So you could always, Elizabeth Altenau is at UNC in Dylan Kelsey's group, and she's the keeper and creator of SWORD. So you could direct questions on SWORD to her. Her info is at the SWORD Explorer link I sent. Anyone else know about those? Do you have more information on that, Merritt?
I do not necessarily. And I think you can still look at SWOT data from the Pixel Cloud product and narrower rivers as well. It could be an option as well. But yeah, for
That's right.
hydrocon access of SWOT, it's limited to the rivers that are in SWORD.
So just to summarize, for a smaller river to be processed and have vector files available, it has to be contained within that SWORD database. And so this would be the critical step for getting those smaller rivers in. And there are definitely people who are trying to work on that. I know that the SWORD database is being updated, but which rivers get included when is not something that we're at liberty to say right now.
Thank you, Mike, Merritt, and Angelica. Question number 28. Will SWOT data also include glacial lakes?
Take that one, Merritt.
Sure. So I believe there are a couple of, or a number of glacial lakes that are available in the SWOT Lake Vector product. And some of these lakes are not necessarily available at this time, I believe, because part of how the prior lake database was developed was looking for lakes that have water a certain amount of time in the year. And so some of these lakes did not make it into that product. But I know, similar to how there's been updates in the SWOT River database, there's also been updates to the prior lake database. And we've also looked at some of these glacial lakes through the raster and Pixel Cloud products, and that is an option too for looking at their elevation data. And also, if lakes are not available in that prior lake database, sometimes they are available through the unassigned lake product, which we are not showing on WISP, but is available to download through SWOT resources.
Thank you so much, Merritt. Question 29. What's the latency for river stages? I mean, how long do we have to wait after the SWOT overpass and the levels of availability within this Viz app or elsewhere?
I guess, Mike, do you know the exact answer?
It's so complicated. I wish
Yeah.
anyone I don't know, Angelica, if you want to, what your normal answer is for that.
So I think the specified date is 45 days, but it's not always that long. And from there, that's available in Podak, but I'm not sure how long it takes then to get into the Viz app. Do you know, Mike?
So the SWOTViz and WISP are pulling via hydrocron, and so there is an intermediate step where this hydrocron is also produced by NASA's Podak, the Physical Oceanography Data Archive Distribution Center, and so they have to like create a separate data product. But from just my own experience and playing around, I feel like you can often be pulling data from like hydrocon within, I don't know, less than a week. But I agree, 45, that longer time is like the requirement. But they often are able to do much better than that. Anyway,
Yes,
it's good to hear how you taught
that's
that. I'm going
right.
to use that.
Okay, wonderful. Thanks so much. Question number 30. Can you suggest any resource to deal with SWOT uncertainty? I plan to process the data myself.
I was gonna try and chime in on this, but I'm curious how others would answer, because I think I have a few things to say. First, it kind of depends what you're doing with the uncertainty, so I might answer differently. I'd say that the in addition to the product description document, I might spend a little time looking at the ATBDs, the algorithm theoretical basis documents, which are also linked at the the link I shared earlier with all the documentation for SWOT. They're pretty thick, but if you want to really get into the uncertainty and error propagation, then there's a lot of information there. That said, the uncertainty estimates themselves, especially for the like single pass products, like the river vector products, so the nodes and the reaches we've been talking about, I think that those uncertainty estimates are still kind of growing in maturity, and that perhaps version E, what's available next year, they might have be able to track with more like precision what the true uncertainty estimates themselves are. It's right, like what's the uncertainty on your uncertainty. But I think that those algorithms are still growing in maturity, is how I've heard the algorithm team describe them.
Okay, thank you, Mike. Question number 31. Another one on lake water elevation. Is it possible to get lake's water surface elevation from SWOTViz?
Yeah, so it hasn't been added yet, but we plan to do it in the future.
Great, thanks so much. Question 32. I am not able to use the SWOT data viewer. Are not all rivers available? I tried for Northern Ontario, but I am unable to view the data.
I'm not sure which viewer that might be in reference to, but if it's for SWOTViz, some rivers don't have any data, any valid SWOT measurements, just for some reason or another. Like a particular reach might lie in like the diamond shapes that the different overpasses make when there's these small areas that are not covered. It's a small number of global reaches like that, but that might be one reason for it. Otherwise, we've had a lot of folks use the app and we haven't seen too many issues, so it should be there. If you do see a river reach that's acting strangely, feel free to email me and I can share that with the Quasi team. Actually, Tony Castronova is on the call today. He's from the leader of the Quasi team that built the app.
And I'll just add that WISP only is showing rivers in the United States, so it wouldn't display any in Northern Ontario.
Great, thank you, Mike and Merritt. For the person that asked that question, if you wanted to clarify your question at all, feel free to either add something to the comment box so that we can view that, or feel free to reach out to Dr. Michael Durand directly. And if that is maybe a river reach that, I don't know, is not in the database, or if it's causing troubles, hopefully we can resolve that question for you. So question number 33, how can we estimate reach discharge from the SWOT elevation data?
I don't know where to start. Spent a lot of time on that question. You know, I'd say clearly, if you're waiting for the river discharge estimates to be available from SWOT, you know, we do expect those sort of later this year. We are there is an effort, the discharge algorithm working group has been pushing for some time to basically enable the level 2, just so you'd have river discharge with each, you know, available in SWOTViz and WISP and everything else available with each SWOT overpass. And so that effort's ongoing and hopefully is available later this year. And if you're asking something else, let me know.
I'll just add that though the data is not available yet, we have some media trying to explain the process of this development that features the hydrology lead from CNES, and I can put that link in there.
I'll just also say that if you're willing to use kind of a more experimental data set, there is the level 4, we call it, data, which is produced by the science team directly. And that is also a data product at PODAC. And I'm just going to post a link to this nice tutorial that was put together on how to access that level 4 discharge.
Wonderful. Thank you so much, Mike and Angelica. Question 34. Can you give more information on the temporal resolution of SWOT observations on land? What is the highest resolution possible and where?
You want that one, Merritt?
Sure. So there's a lot of, or there's some information within the SWOT River database, for example, that includes the passes and how many passes per a given river or lake there is, for example, in the prior data sets. And basically the temporal resolution is a function of how many times that water body will be observed by the satellite. And for example, in the continental United States, that's an average of 2 to 3 times per that 21-day orbit. And at higher latitudes, this number increases potentially to 5 or 6. And I believe that that's roughly the range. And so some water bodies will only be observed once in a 21-day orbit, but most will be observed several times. And so on average, the temporal resolution is, you know, like 8 to 10 days, but the timing in between those overpasses might be different. And so you could have an observation, for example, on the first day, the 4th day, and the 20th day, if you had 3 within a 21-day orbit. And so you would have different gaps, if that makes sense. And so it's dependent on the water body. But there is, yeah, a number usually per water body. And the highest resolution possible would be at higher latitudes.
Okay, thank you so much, Merritt. Question number 35. How can we download data for all available US lakes at once? Is it possible to do that? Which website is the easiest and most efficient for downloading this type of data? Also, do the datasets generally cover the same time period across all lakes?
That's a great question. So WISP does display US lake data, but at this time, we don't really support bulk downloading. So in order to download all of the lake data, currently you would have to click on each lake and download that time series. WISP is kind of designed more to explore the SWOT data, and we encourage folks to check out the Hydrochrone application programming interface if they want to explore bulk downloading of all of the data. And I haven't yet posted it, but there are some resources on downloading many links at once that have been shared. And I really think the Hydrocon tool is great for sort of downloading a lot of data at once. And the SWOT lake level data is generally covering the same time period across all of the lakes, but some of the lakes, especially in the US, fall under the fast sampling orbit. So there's data beginning at an earlier time period. And roughly that's about April of 2023 if it's in the fast sampling, and closer to October or November of 2023 if it's not in the fast sampling, I believe.
Wonderful. Thank you, Merritt. This is a follow-up to a question we had earlier, following on question 8, that question 8 being, what data product is WISP visualizing? This person's question is, I would like to know the actual product since there are several level 2 SWOT data products.
That's a great question. I can definitely go in and kind of post the actual citation to these products, and we'll be sure to share that out. In short, we're displaying the level 2 river SP product, the node SP product, and the lake SP product. And those products right now correspond with SWOT version C data that is available through the Hydrocon API.
Okay, thank you, Merritt. Question 37. I saw that WISP covers big rivers like Rio Grande in New Mexico. I'm wondering if there are any resources for small rivers like Santa Cruz, which I see are not covered by the WISP.
That's a great question. So WISP is only displaying links that are in that SWOT river database. So for rivers that are too narrow to be in the SWOT river database, there are potentially options in the future to include some of those rivers or to use other SWOT data products like the SWOT Pixel Cloud product for those sites. And there's a chance that they might just be kind of too small to routinely and accurately observe with SWOT. But there are also other satellite remote sensing products to look at narrow rivers. For example, the dynamic surface water extent product could be used, which uses optical satellite imagery for smaller rivers.
Okay, thank you so much, Merritt. Question 38. Given SWOT's 21-day revisit cycle, how suitable do you think it is for capturing transient coastal processes like storm surges or river plumes?
Yeah, so I'd love for other folks to weigh in. I'm not a coastal person in terms of my research focus, but I think, of course, you don't, if you're going to see it somewhere 2 or 3 times per 21-day cycle, you're not going to resolve all of the details of the tidal cycle and everything. But I just wanted to highlight that the orbit was chosen. Actually, the oceanographers that design, help push for different parts of the mission design chose the orbit to be non-tidal alias, which means that, kind of like I showed in the for the Garone in the training earlier, you kind of catch the cycle at different points with each new 21-day SWOT cycle. So, you do see different parts of it, and that may be useful for some applications, but you won't ever resolve the full thing. One last thing is just not to forget about the fast sample data. So for 3 months, the satellite was in a 1-day repeat orbit for a small number of places that it sees, but at those places you might catch some of these fast changing processes a little bit better. So 1 observation per day on those during that time.
Great, thanks so much, Mike. Question 39. What tools do you use to convert SWOT elevation to USGS gauge elevation?
That's a great question. So within WISP, we are not actually converting SWOT elevation to USGS gauge elevation, but if instead we're just showing a relative comparison between the two, if we have observations for both a gauge and SWOT. But that being said, if you did want to convert between the EGM 2008 geoid and NAVD 88, for example, you could use the VDatum tool, which I'll be sure to post a link to. It's a datum conversion tool put out by NOAA. And there's also other options out there for these types of conversions as well.
Thank you, Merritt. Question 40. Does SWOT need atmospheric corrections?
So the short answer is yes. The SWOT satellite does have a radiometer, and it's used for things like the wet path delay, and the LR products, the low rate data products that are primarily intended for ocean data users, are distributed with a dynamic atmospheric correction, and this the source of this can change depending on which data set you are actually looking at.
Great, thank you, Angelica. Question 41. Based on the review of some recent works on SWOT, it can be observed that the meridional component of the currents does not provide significant contributions, unlike its zonal component, which offers more precision. Why is there this difference between the two components?
I'll just chime in to say I can't address that. I don't know if others can.
It would be helpful to answer this question if they have a reference for what their which study they're thinking about. But I'll just say that historically, ocean velocities provided from altimetry rely on the critical assumption of geostrophic flow. And with SWOT, specifically the Karen data, we are resolving fronts and filaments and ocean features that we've never been able to resolve before. And so certainly we can go ahead and try and apply the same equations, but I would tread with caution in calling them geostrophic velocities, because those assumptions that are embedded within that formulation may no longer hold at these scales. And so I think there's a movement to start calling these absolute velocities, but it's an active area of research, certainly.
Great, thanks so much, Angelica. Question 42. Why are some data flagged as suspect? I have looked on a yearly basis, but I found mainly suspect data and large variation in the elevation. It is true that weather is chaotic, but how could we manipulate the data for meaningful analysis? Shouldn't we be having weather multi-layer integrated in SWOTViz? Is the data functional with QGIS, example, GeoTIFF?
Yeah, so let's see. I think we've mentioned earlier that most data currently flagged as suspect. One thing I wanted to emphasize with that, because we've highlighted already how we expect that to change in future, but most of the data flagged as suspect are very usable. I just wanted to highlight that in case to avoid the impression that suspect means it's not usable. So there are papers being published regularly using the suspect flag data, but just have to treat it with caution. Some suspect data is indeed poor quality. Yeah, we're not planning to add additional data sets to stage and visualize in SWOTViz. It's going to remain a pretty lightweight app. You have a good funding source to support a build out of many other features, let us know. We should have mentioned HydroWeb Next, I think, too, which is a an app created by the French Space Agency, and please chime in, Merritt, if you, I think it's still called HydroWeb Next. But that it has a number of more features, and it does support looking at multiple different data sets. I don't know if they include weather data sets or not. You can definitely download vector data from SWOTViz. That'll probably be like a CSV type format, and then you can visualize that in QGIS, but it's not a GeoTIFF, so SWOTViz does not support rasters. So this is all vector data. SWOTViz is only doing vector data. So if you want to look at rasters or pixel cloud, then you can you'll have to get those a different way.
Question 43 has been addressed several times. What is the datum used to give the SWOT water surface elevation? So whoever asked that, please refer back to this document once it's posted to the training page. Question 44, what improvements are expected in future level 2 and level 3 data releases, especially for coastal accuracy?
So with respect to the ocean products, the low rate data, there is a level 3 product available from Aviso, and the latest release actually has an update to some of the coastal masking to allow for more accurate representation of coastlines, and this tends to allow us to actually keep more data in those regions. And I suspect that once we start looking closer at version D, we'll also have some improvements on flags and similar things that allow us to have greater trust in the products and coastal zones. And last thing I'll say on this is that a lot of the hydrology products actually could be relevant to coastal processes as well, just as Mike was showing that you can see tidal propagation in these rivers that are tidally influenced. And so for depending on what type of study you're interested in, the things like the Pixel Cloud product may be a good tool to leverage as well.
Wonderful. Thank you so much. I do see, I want to respect everybody's time. I see that we're 2 minutes until the end of the scheduled cutoff time. So we do understand there are roughly 5 questions that have not been answered. But for those that did pose those questions, please be reassured that they will be addressed and your answers will be posted on the training page within the coming week. So if you did have a question and you submitted it and was not answered today, please do check back on that training page within the week. But as we're wrapping up, this is the final part of this webinar series. And one, I want to thank everybody so much for joining. We've had a tremendous number of participants joining from all over the world. Wherever you are joining from, thank you so much for taking the time out of your schedules and for your interest in one, strengthening the community to use these resources, these NASA resources in your work and your research, if it's on the job. But thank you so much. And a special thanks to Dr. Merritt Harlan, Dr. Michael Durand, and Dr. Angelica Rodriguez. Thank you so much for providing your expertise, providing the time that you gave to this training. And as we wrap up this training, I did want to give Merritt, Mike, and Angelica, maybe in that order, just an opportunity to maybe have any comments as we wrap up to the participants that are joined today. So maybe Merritt, we can start with you. Thanks.
Sure. Thank you so much for attending. This has been great, and I've been really enjoying all the feedback, and I hope that you all get a chance to check out WISP if it might be of interest. And please don't hesitate to reach out with any follow-up questions or ideas for improving this site or any collaboration. And I'll turn it over to the other presenters. Thank you.
I missed the suggested order, but I'll chime in. I hope I'm not jumping in front of you, Angelica. But yeah, just to echo what Merritt said. This was so meaningful and interesting and enlightening to engage with all of the questions and the way that folks see SWOT when you see it after preparing for this mission for so very long. It's just super exciting to see people using the data. So if you have any, similar to what you said, Merritt, if you have any thoughts or insights or ideas to improve SWOTViz in future, please do reach out. I'd love to hear from you. Thanks, everyone.
Yes, just agreed that it's really exciting to see so much interest in SWOT, and I truly appreciate Merritt and Mike participating with us, and for all of the ARSET folks for arranging this training. It's been eye-opening to see how many people are looking for this sort of support, and it's very useful for us to see these questions and for us to figure out ways to relay this information more plainly and openly. And I will definitely be taking this back to our team with the mission.
Wonderful. And again, thank you so much, Dr. Harlan, Dr. Durand, and Dr. Rodriguez. Hopefully you're seeing all of the appreciation coming in, pouring in from all the participants today. So many thanks to you all. Again, thank you everybody that was joining today from wherever you are around the world. Thank you. And also I want to thank and acknowledge the ARSET team working tirelessly in the background to put this on. Selwyn Hudson-Odoi, Brock Blevins, Natasha Johnson-Griffin, Dr. Amita Mehta, and Sarah Larson. So thanks so much to the ARSET team. And we look forward to seeing you all at our next ARSET training. Thank you and be well.